This video is part 1 of Chapter 6, Independent Groups Designs for PSY 222, Research Methods in the Psychological Sciences. We're going to start by exploring and just sort of reminding ourselves of why psychologists conduct experiments in the first place. We'll start by just asking some questions. What are the good things about experiments? What are some of the challenges when we use experimental methods in order to ask and answer questions? So it's good to kind of backtrack and say, why are we using these methods in the first place? So first is kind of the obvious answer to why psychologists conduct experiments. First, we want to test hypotheses. We can have hypotheses, we can have a lot of folk wisdom that tells us what's probably true, we can have intuitions about what's probably true, we can even have lots of previous research that has demonstrated what's probably true. But we also want to test hypotheses ourselves. And what we're primarily interested in when we're doing experimental research, as opposed to doing correlational research or descriptive research, is that we're after cause and effect. We want to determine the causes of behaviors. So sometimes we're testing hypotheses that come straight from theory. So in my world, in social psychology, maybe I'm testing a hypothesis related to, say, self-affirmation theory or cognitive dissonance theory, for example. Then, once I've done the testing of aspects of the theory, I can go back and say either the tenets of the theory were supported or they were partially supported, and if that's the case, then the theory needs to be revised or adjusted. Maybe I find data that refutes an aspect of the theory. Then the research, when reported in the literature, can be debated among other researchers conducting similar research. And that's a real important part of the culture of science, where findings from experimental research are plugged into the rest of the research literature, and theory is advanced as a result. We also conduct experiments in order to solve important problems. So you may want to test effectiveness of treatments and programs, for example, and your authors emphasize that. I would also add that sometimes current issues will pop up and researchers will want to test experimental hypotheses related to those. For example, since the advent of smartphones and iPads and other kinds of tablets, the question has been asked repeatedly, what's the impact of using these devices in a whole host of areas? So you could ask questions about impacts on behaviors, and that becomes, a way of solving a problem for us. In experimental research, your authors make a point of saying that experiments should be, ideally, a part of a multi-method approach. There is no one-size-fits-all best method. Over the course of my career, I have run into psychologists who are very much experimental purists, and they believe that the only type of research that's good is an experiment where you are systematically manipulating variables and controlling other variables and measuring variables of interest, and therefore enabling yourself to make causal conclusions. I'm not one of those purists. I believe that in order to fully understand behaviors, we need to use multiple methods. We need to use powerful descriptive methods, we need to use correlational methods, and we need to use experimental methods, each of which has limitations and advantages. Definitely the advantage of the experimental approach is that you can make cause and effect statements. Where it's weaker, and that's what we'll be kind of exploring across this chapter, it's weaker in terms of what's called external validity. And as I said, we'll be exploring that along the way. Using a multi-method approach balances out that weakness. So when we lose naturalism by having a laboratory experiment, for example, we can balance that out by doing field studies, correlational research, and descriptive research. Now, the logic of experimental approaches is as follows, and this is probably review for you. Most of you throughout your high school and middle school and probably even elementary school education have been exposed to the basics of the experimental technique. And you may have been exposed to this in other college courses as well. The basic logic of experimental work means that you have chosen a variable of interest that you believe has some impact on another variable of interest. You're going to systematically manipulate the variable that you think will have a causal impact on another variable that you're interested in explaining. The variable that you're manipulating is what we call an independent variable. I don't know if you had to do this when you were in school, but my oldest child, who is around your age, when she was in, I believe it was biology, they had to do this infamous Marigold study where what you were manipulating was the amount of acidic substance in the water that you watered your marigolds with. So we had to get all these little tiny Dixie cups and some marigold seeds and set up basically a little lab garden in the kitchen, and you mix these solutions that have different levels of acidity in the water. And so what was being manipulated, because the hypothesis was the higher the acidity of the water, the more inhibited growth would be of these little marigold plants. So what was manipulated? How much vinegar was in the water, essentially. And if memory serves, there were 3 groups. You had no vinegar, you had a middle group that had, I forget what percentage, but a middle range percentage, and then a high percentage. And, not surprisingly, the plants that grew the best were the ones that were not exposed to vinegar. The plants that grew the worst were the ones exposed to the highest level, and the ones that were exposed to the middle level grew moderately. Frankly, the ones exposed to a lot of vinegar just basically died. So what was manipulated was how much vinegar was in the water. Now, if you remember an example from my own research, I manipulated in my study of the effects of viewing stigmatizing television material. What did I manipulate? I manipulated the program type. So they either watched a highly stigmatizing television program that had both violence and mental health content, or they just watched the same kind of program with just violence content but no mental health, or a control condition. So what was I manipulating as my independent variable was program type. When I use experimental control, what that allows me to do, and by control what we're talking about is keeping lots of things consistent, keeping the environment in which data is collected consistent. So in my study with television programs, I had all of my participants came to a lab room where we set up a TV and a DVD player, because we still did that back then. They all sat in the same room. They used the same computers in order to enter their online survey results, or responses rather. They had essentially the same research assistant who collected the data in every session. That's controlling. So I'm controlling the experiences of my participants such that they cannot interfere with my ability to conclude at the end of the day that it was the manipulation of the independent variable that caused the change in my dependent variables of interest. The experiment, at its simplest level, experiments have to have at least one independent variable that you manipulate as the researcher and one dependent variable that you measure. So in the Marigold study, you had one independent variable, the amount of vinegar in the water, and there were 3 levels, 0, middle, and high. In my study, My first independent variable was program type, and there were 3 levels. There was violence plus stigmatizing material, violence only, and a control condition. You also have to have at least one dependent variable. In the Marigold study, the dependent variable was how tall were the plants, and it was measured over time. In my stigma study, it was attitudes towards people with mental illness. One of the scale scores was perceptions of dangerousness, for example. And what I was looking for was changes, differences across groups in their dangerousness ratings. So let's review what independent and dependent variables are. And I will say that over the course of my now almost 3 decades of working with students, it's very easy to forget what these are and to become confused about what they are. And working with seniors for as long as I have in their senior research, we often have to review this. So try and carve out a space in your brain for what these variables are. Independent variables, or IVs, are controlled by the experimenter. They are the variable that you believe is going to impact the behavior that you're interested in explaining. So in my research on stigma, for example, I believe that the type of television program that people watch, if programs have stigmatizing content, they will have harsher attitudes towards people with mental illness. So the manipulated variable in my study was program type. So I choose 3 different program types so that I can make critical comparisons. And I believe that which type of program they see should have an impact on the behavior that I'm interested in, which is one of the many was perceptions of dangerousness. And my hypothesis was that if you watch stigmatizing content, your perception that people with mental illness are dangerous will go up. The dependent variables are things you measure. And it's usually the behavior, the thoughts, the attitudes, whatever, that you want to have a better understanding of. You want to know what causes them. You want to know what affects them. So I often call dependent variables outcome variables, because you're going to do things like manipulate a variable, expose them to different conditions, that predispose to different conditions, and then you're going to measure something. So it's an outcome of your manipulation. I often call them measured variables. What you're doing with these variables is being able to look at some aspect of behavior, cognition, or emotion that you are trying to explain, and you're going to use it to determine the impact of the independent variable manipulation. So typically what researchers are going to do, they're going to measure several dependent variables at once. So for example, in my stigma study, I measured not just dangerousness, but willingness to help, beliefs about the causes of mental illness, and so on. When we make causal inferences, there are certain rules that we have to be mindful of. You can't just make causal inferences on scant evidence. You need to have certain kinds of criteria met. So the first thing that you have to be able to show is that, in fact, there is a correlation between the variables that you're interested in. Or you can say it in the way that your authors do, there has to be a covariation. So the first thing you have to be able to demonstrate in your research with your data is that you have been able to observe that there is a relationship between your independent and dependent variable. The second thing you need to show is that the variables, their particular relationship has a specific temporal sequence or time order. So think about, I walk to my light switch, I flick the switch, and the lights go on. I flick the switch again, the lights go off. The light coming on doesn't move the switch. So that's a temporal sequence. When I'm thinking of my media study, I have them watch the program. I look at the evaluation of their attitudes, and I compare groups in terms of their attitudes. I can say, after that manipulation, that watching the program came first, the change in attitudes came second, not the reverse. So that temporal sequence is an important component of being able to demonstrate cause and effect. The way your authors put it, in other words, is the difference in the behavior is contingent on the manipulation. That means any change in your DV, your outcome variable, is contingent on the level of the independent variable. The third requirement, to me, is the most important. Those first two, you can find lots of ways of documenting that and showing that you have covariation and time sequence. However, the hard bar to overcome is the ability to eliminate possible alternative causes. And you do this by carefully controlled experimental procedures, holding extraneous variables constant, using very systematic data collection methods, basically being really, really hyper regular in the way, almost perfectionistically regular in the way you collect data across your participants. And also it includes the way in which you select your sample and then assign them to groups. Doing so can enable you to exert experimental control and eliminate alternative causal explanations for whatever findings you might generate. What we're really talking about here is something called internal validity. And the real advantage of experimental methods is that they tend to be much higher in internal validity, which I usually refer to that as the degree of experimental control that we have when we design the study. The experimental technique gives you high internal validity. When we're talking about comparing groups and trying to demonstrate that there is a meaningful difference between groups that was caused by our manipulation of the independent variable, that's contingent on the degree to which we have high internal validity. So when we're interpreting that data, we need to be able to say with a high degree of confidence that's based on the way we've designed and conducted our study, that the only thing free to vary, the only thing that's a good explanation for differences between groups is the manipulation of the independent variable. When we have violated that, so let's say in my study of media effects, let's say that, and this kind of happened in one of our pilot studies, we had failed to recognize some language that showed up in our violence-only video that we had chosen, and we missed a segment in that program where suicide was mentioned, and we were concerned that that was a confound because we had selected the episode thinking it was just purely a murder case. There wasn't any mental health content at all, and it turned out that there was. It was sort of a secondary storyline. That becomes a confound. Another example of confound, let's say that in my data collection I have 3 levels of my IV. I have the violence plus mental health content TV show, I have the violence only TV show, and I have the control show. What if I only collected the data for the violence plus mental health content in the morning, and I collected the violence only data in the middle of the day and the control group at the end of the day? If I systematically did that, time of day becomes a confounding variable that's problematic. So when confounding happens, what you've done is to introduce an additional possible explanation for why any differences that you do detect between the groups have occurred. When confounds exist, then you've damaged your internal validity, and you have to really qualify any kind of conclusions that you make. When you have plausible alternative explanations, you have to then really kind of downplay the degree to which you can make a causal conclusion. So after that pilot study that I mentioned earlier, We scrapped that episode, replaced it with a better episode that we had carefully screened, and redid the pilot to make sure that the manipulation was effective. There are many different types of independent groups designs. The one that you have probably had the most familiarity with is called a random groups design. And we'll give more detail about each of these here as we go along. There's also something called a matched groups design, where you are building in some additional control of potentially confounding variables by matching your subjects based on their demographic attributes. And then there are natural groups designs, where you have people who you want to study who kind of come into the research with their own attributes, and you study those demographic attributes often as independent variables. So for instance, a lot of studies comparing males and females are natural groups designs. With random groups design, and again, I said that this is probably a design that you have the most familiarity with, because in our school systems, we tend to use the idea of random groups designs as the kind of epitome of experimental design. In this version of a between groups design, what we're doing is randomly assigning participants to conditions of the independent variable. So in my media study, for example, we had, everyone who signed up, they were randomly put into one of the three independent variable groups. There was no systematic way of putting people into groups, say, based on their preference. They couldn't choose which group they were going to be in. They were randomly assigned. And each participant is in only one condition of the independent variable. So there were no overlaps. If you were in my study, you were in one group and one group only. You saw only one video, right? Random assignment is used to create what are called comparable groups. What you want to do, because every individual who comes into your study is going to have their own unique background, their own experiences, their own attitudes, their own demographic attributes. They all have their own messiness. What we do with random assignment is basically spread out the mess and kind of balance the participants off of each other by randomly assigning them to groups. So basically, you're spreading out the error that's associated with their individual differences by putting them randomly into the different conditions within your experiment. When we use random assignment to create these groups, that's what's referred to as a random groups design. And there are many variations of random groups design, and your authors mention a handful of those. Now, I screenshotted this image because it's a useful example in your textbook that you can look at when you have more time to really look at the method. This is a study that comes up in later chapters too. And it's an interesting piece of work, but it's an example of a random groups design where they looked at girls. These were school age, what would be the equivalent of kindergarten, first and second graders in the United States. They were assigned to look at one of three different picture groups, and the girls were randomly assigned to those groups. Now, age is a pre-existing variable, but we're just talking about their random assignment to see different kinds of picture books. In one of the picture books, they saw an image of a classic Barbie doll. In a second version of the picture book, they saw a doll comparable to Barbie, but imagine Barbie wearing a size 16, a so-called body-positive Emmy doll, and then neutral images, not of people. And they wanted to compare what would be the impact on variables such as body dissatisfaction and other kinds of variables. So the girls were randomly assigned to which picture book they would see and be exposed to. Now we're going to go back to the logic of causal inference here for a moment. When we randomly assign people, participants, to conditions of the IV, we can we can get closer to making the assumption that the groups are equivalent. So, assuming that you don't have any systematic way that you've like ended up with mostly freshmen in one segment of your experiment and mostly juniors in another, you have to protect against that. So one of the things that we have to kind of ensure to make an eventual causal conclusion is that our groups are initially equivalent before we manipulate the independent variable. So what researchers often will do is they'll do some pre-testing. In some versions of my stigma study, for example, we did pre-test dangerousness ratings. So we looked at specifically the variable dangerousness, how dangerous do you perceive people with mental illness to be, and at pre-test we compared the groups and we found that they were in fact equivalent. There were no significant differences between the groups before the manipulation. The manipulation was which television program they watched, and then we did a post-test to look at it. That's a way that we can examine and ensure initial equivalence in a different kind of design. But I think it illustrates what your authors mean when they say you need to be able to assume that you have groups that are equivalent across their various attributes when they come into your study. And if that's the case, then they kind of balance each other out. So for instance, if you have participants of different education levels, you want to make sure that the various levels of education are equally represented in each of your independent variable conditions. The result is, when you've done this well, any differences among the groups, you should be able to conclude that they are due to the IV manipulation and not to some systematic attribute that actually differentiates the groups, because you've balanced them. Now, a more complicated version of randomization that can be used in these designs is something called block randomization. In all my years of working with seniors in their SEE research, I have yet to have to do block randomization. These are challenging designs, but they're often used when you have multiple conditions of an independent variable. In this image, for example, what I am showing you here is that you've got 5 conditions, A, B, C, D, and E. So there's 5 different conditions people could be assigned to. One way that you can ensure randomization is that you can create blocks of participants. So in this example, in this image, I have blocks of 5 participants, and I randomize the conditions that are going to go inside that block. So within my block of 5, each participant will get only one condition that they'll be exposed to. What I do across blocks is randomize the order of the conditions. So it's an extra layer of randomization. Essentially what you're doing when you do block randomization is you're assigning subjects to one block at a time. Some of the advantages of this: you are creating some groups that are of equal size. It can enable you as a researcher to say, okay, when I do the conditions this way, are there differences across blocks? It can help you to show that there aren't or there are, and so on. By randomizing the order of the conditions as they're assigned to people within blocks, it helps to control for time-related problems. So time can be a confound, and by doing block randomization, you're able to control for that. So that concludes part 1 of chapter 6. I'll see you again for part 2.